Hello guys, welcome back to lecture series on Z transform. So I have already uploaded plenty of the lectures in my channel. So if you are interested to see this video, go and check in I button. So you'll get in playlist down here in my description also. Okay, so in my today's video, I'm gonna explain to you all second property for the Z transform, which is the Z of a raised to k can over k less than 0, Z upon a minus z and mod z less than mod a. Okay. So a similar property we learned in our previous lecture only when k greater than equal to 0. Okay. So but when what happen if k smaller than 0, like a 0 to minus infinity. Okay. So in such a case, how can we deal the situation? Okay. Yes, now see that as we are going to take the value from smaller than 0, so our summation need to be changed there. Okay. Yes, so let me write a Z transform. Okay, Z transform of function. So Z transform of a raised to k. Let me write Z transform of a raised to k. Okay, and k greater than 0. Okay, so no need to write. We are taking as minus infinity to plus infinity, because as we are taking negative values over here. Okay, minus infinity to plus infinity f of k z raised to minus k. Okay, this one is our required definition for Z transform. Okay, this one is the definition we are going to apply here. Yes, but now see that as we have conditions k smaller than 0, replace the value. Okay, z of a raised to k and a k smaller than 0, can be written as, okay, minus infinity to plus infinity. Now see that as we have value, all the value which is a minus 0 and smaller than 0, that means minus 1, minus 2, minus 3 up to the minus infinity. We don't have the positive value. Okay, so we consider minus 1, k running from minus 1 to k running from minus 1 to minus infinity. Okay, k minus 1 to minus infinity. Okay, so what is the value for f of k? Is a raised to k. Okay, and z raised to minus k. Okay, now see that this one is actually replaced value over here. It is way easier, guys. So as we have k smaller than 0, so that's why I taken minus 1 to minus infinity. But as we have our limit over minus 1 to minus infinity, we are not taking negative limit here for summation. So I'm going to replace that negative limit into some positive values. Okay, so try to replace the negative limit. Okay, so as value for k running from minus 1 to infinity, so I'm going to replace it is the positive. So what can I write k as a some another value? Okay, so if I consider k which is equal to minus m, okay, put what I'm going to do, I'm going to put the value for k is minus m. I do not want that negative limit, negative 1 to negative infinity. Okay, so I do not want that negative limit, so I can consider k is a minus m. Okay, k is a minus m, so whatever the value it is coming for k, it gives us the positive. Already minus 1 is there and again minus m, so it gives us the positive. Okay, so if k is a minus m, I consider here. Okay, so if k is a minus 1, let me replace the powers also, their values also. If k is a minus 1, if k gives us the, I consider k as a minus 1, what is the value for m then? Then we write m which is equal to 1. Okay, how 1? K is a minus 1. Okay, so minus 1 which is equal to minus m, so m which is equal to only m remaining. Okay, 1 remaining. If k is a minus infinity, okay, I consider k as a minus infinity. Now see that it is minus infinity here now, so I consider k is a minus infinity. So minus infinity which is equal to minus m, so we write m which is equal to infinity. Okay, so as you are replacing these values over here, you have to replace that power k also. Okay, yes, so if you are replacing that minus 1 to minus infinity, so replace the power also in the form of minus m. Okay, yes, so put the values here. Okay, so what we write, z into a raised to k is k running from minus 1 to infinity, so I'm going to replace that m which is equal to 1 to m which is equal to infinity. Now see that when k is a minus 1, I return m is equal to 1, and k is equal to minus infinity, I return m is equal to infinity. Okay, now a to the power k. Now see that as we are taking limit in the form of m, so what you need to do, you have to replace that k into the form of m. Okay, so what we write, k is a minus m, so a to the power minus m, so we write a to the power minus m here. Okay, k as a minus m. and z raised to minus k, as k is again minus m, minus minus we write plus m, okay, then we write z raised to plus m, okay. This is the actual value, this is the actual value for our sequence here, okay. I hope you all have understood guys, not the difficult, okay. It is one of the easier, just need to replace the value as I want the limit over 1 to infinity, okay. So we run a limit from positive values, okay. Yes, so what we go for the expansion of the term 1 to infinity, put the value here. So I'm going to write next step as a raised to minus 1 z raised to 1 plus a raised to minus 2 z raised to 2 plus a raised to minus 3 z raised to 3, okay. A raised to minus 1 z raised to 1 plus a raised to minus 2 z raised to 2. Replace the value 1 2 3 up to the infinity, and as a summation take their addition. A raised to minus 3 z raised to 3 plus a raised to minus 4 z raised to 4 plus so on, okay. This one is the expansion, okay. This one is the actually expansion for the term. This one is the expansion. Now what we do, we are trying to take into the some geometric term form, okay. So that means we write first term as a 1, second term as x square, x cube in such a form, okay. Yes, let me take to the next page, I will explain over here, okay. Yes, so what we have term a raised to minus 1 z raised to 1. Let me write this step one more time. So see guys, I written these steps again over here. So I'm going to convert this one into the some geometric form. So what we do, we have 1 as a first term, so we don't have 1 here. So take a raised to minus 1 z raised to 1 common, a raised to minus 1 z raised to 1 common, under bracket if it goes outside we write 1, okay, plus we have to take that term common from here and all the way up to the infinity, okay. Yes, so a raised to minus 2 z raised to 2, I taken a raised to minus 1 z raised to 1 common, okay. So we left here a raised to minus 1 z raised to 1 plus. So you can take this term under bracket here, you will get the required term, okay. Now see that how can you get a raised to minus 1 z, as it is here, a raised to minus 1 z into a raised to minus 1 z raised to 1, okay. So when we have base same, we add their power, you will get this term, okay. Again we here a raised to minus 2 z raised to 2 plus a raised to minus 3 z raised to 3 plus all the way up to the infinity, okay. So this one is now, it's look like some sort of geometric series, okay. Yes, so what we do, we take a raised to minus 1 z as it is here under bracket, okay. A raised to minus 1 z keep as it is, under bracket we take 1 plus a raised to minus 1 z plus, take power to outside, a raised to minus 1 z to the power 2, okay, plus a raised to minus 1 into z to the power 3 plus a raised to minus 1 into z to the power 4 plus so on, okay. This way I written this term over here, okay. It's one of the easy guys, not the difficult. I need to take their powers outside here, okay. Yes, so you can see that 1 plus x square plus x cube plus x raised to 4 plus x raised to 5 plus up to the so on. This one is a infinite term, okay. As we can see here, the all terms are having common common ratio, it same everywhere, okay. Whenever common ratio is same, we consider it the geometric progression, and when we have geometric series, we write 1 upon 1 minus a common difference as it is the ratio, okay. Yes, so a raised to minus 1 upon z, I already explained, 1 plus x square plus x cube plus so on can be written as 1 minus x raised to minus 1. So 1 minus x is a raised to minus 1 z to the power minus 1, okay. This one is the expansion for this term, okay. So if you don't know, let me write this part. 1 minus x raised to minus 1 can be written as 1 plus x square plus x cube plus x raised to 4 plus so on, okay. This is the way we write a geometric progression for our sum of infinitely many terms, okay. Yes, so a raised to minus 1 z can be written as z by a. I'm going to write a raised to minus 1 z as z by a. Under bracket I'm going to write 1 upon 1 minus a raised to minus 1 z, okay. Bracket complete. Minus 1 I taken to the denominator only, that one it is, okay. Don't have anything more, okay. So z by a take it inside, okay. So z upon a into 1 a plus A into A inverse. Now see that A into A inverse, how I'm going to write? Okay, so I'm multiplying that A to the here and here also. So A into 1, it remain A. Okay, yes, so A, so it is negative sign. Okay, this one is a negative, guys. This one is the negative. This one is a negative. So I multiplied A here. A into A inverse, I'm going to explain. Okay, A into A inverse means A into 1 upon A. Okay, A and A cancel, it means it remained 1 only. So A minus Z. Okay, so we write this expansion Z upon A minus Z. Okay, this one is our required proof. Okay, that one we want now. Yes, we are on the right track. Mod Z, that Z need to be smaller than mod A. Okay, yes, this one is our required proof, guys. Okay, I hope you all have understood. Nothing it is difficult, just need to apply some basic results for finding the solution. Okay, proof of our statement. I hope you all have understood this entire proof for my property. Okay, this one is the entire property over here. So for your reference, you can note it down. Okay, pause the video, note down this property. Okay, so I'm going to solve one of the example that you all can understand. Okay, already I solved similar example. Okay, already I solved similar example based on such a properties. So we go for solving one more property here. Okay, yes, one more example here. Let me write the example that can be helpful for visualization of the concept. So guys, I consider here one example. Okay, so this example can explain the two of the property that I explained earlier. Okay, it is way easier. Now see that this one is a piecewise sequence. Okay, one represent 3 raised to k when k 0 or bigger than 0, and another part of a sequence when k smaller than 0, we write 4 raised to k here. Okay, yes, now see that guys, we are not going to apply all the hectic process that given in a definition of a Z transform, as we have directly the standard form for a Z transform. Okay, standard form for Z transform, I'm going to apply that one directly over here. Okay, yes, now let me write the standard form of our Z transform. Okay, that we have our two standard form. Okay, when we have Z of A raised to k, let me write the standard form here for you. You need to understand this one. Okay, yes, Z of A raised to k. Okay, so we learn Z of A raised to k, expansion of a Z transform. Okay, expansion of this Z transform when we have k smaller than 0 and k greater than equal to 0. Okay, yes, we take first of all k greater equal 0. Okay, when terms are big 0 or bigger than 0, we write Z upon Z minus a. Okay, we write Z upon Z minus a. And when we have, this one is the first result, and when we have second Z transform over A raised to k, okay, and k smaller than 0, okay, when such a condition it is there, okay, k smaller than 0, then we write, okay, this expansion we write Z upon A minus Z. Okay, Z upon A minus Z. Now see that this is only replacement. Okay, this is, it's easier to remember, guys. How can you remember? 0 when all the positive terms are there now, 0 and including positives, we write Z minus A, and when all the negative term goes to the infinity, we write Z upon A minus Z. Okay, this is just altered value over here. Okay, yes, that is only. Now let's expand this sequence. Okay, let's expand this sequence using these two formula. So first I have piece of the sequence f of k. Okay, f of k. What the first f of k gives us? 3 raised to k and k greater than equal to 0. That means we apply this sequence over here. Okay, yes, so we write Z transform over 3 raised to k and k greater than 0. Okay, can be written as Z upon Z minus A. What is the value for A? Is a 3, Z minus 3. Okay, now see that how easy, guys. We need to replace only the values. So what is the A here? A means A raised to k means 3 raised to k upon Z minus 3. Okay, now let's go for the another piece of our sequence. What we have? Small f of k, it can be written as 4 raised to k. Okay, and k smaller than 0. Okay, let's write the, it's a Z transform of 4 raised to k. Okay, Z transform of 4 raised to k and k smaller than 0 can be written as Z upon A minus Z. What is the value for A? It is 4 minus Z. Now see that I got these two values, this one and this one. These are the two values I do have here. Okay. Yes. Now I'm going to merge. I'm going to merge this f of k. Okay, as we have z transform over f of k as the part of piece. Okay, piece of the two function. That means we are taking the addition between intervals. Okay, addition between interval as we learn in our integral also. Okay, so whenever we have piecewise function, we take the pieces of integration, and between that pieces we take the addition, because this is the part where we take 0 to minus infinity and 0 to plus infinity. Okay, yes, this one is the part. So I'm going to write this sequence as z sequence of f of k, sequence of f of k. Okay, f of k, I'm going to write the z transform of f of k. Okay, which is equal to z transform of 3 raised to k plus z transform of 4 raised to k. Okay, and 3 raised to k when k greater equal 0, 4 raised to k when k smaller than 0. Okay, this one is the expansion for our z transform. Okay, this one is the required expansion for z transform. So go for the replacement of values, guys. What the replacement we have here? Z of 3 raised to k is a z upon z minus 3. Okay, so I'm going to write this one as a z upon z minus 3 plus z of 4 raised to k, z upon 4 minus z, z upon 4 minus z. Okay, this one is our required z transform. See that, guys, how easy it is. I solved this example in a 3 to 4 steps only. Okay, for your reference you can take the note of this example. Okay, this is the example cover our two properties we taken it before. Okay, yes, I hope you all have understood, guys, everything I taken here in my today's lecture. It's nothing difficult. Okay, so even after, if you found anything difficult, guys, let me know in my comment section. I will come up with a similar video. So thank you everyone, thank you for my today's video.